Hello everyone, thank you for watching. Today we'll be identifying the Lewis dot structure for carbon dioxide, also known as CO2. So obviously before solving for this Lewis dot structure, we must do a couple calculations. Firstly, we must find out how many valence electrons are in each of our elements. Carbon is located in the fourth column, therefore it has 4 valence electrons. On the other hand, oxygen is in the sixth column, so it has 6 valence electrons. Now let's tally up our total valence electrons in carbon dioxide. As we remember, oxygen was in the sixth column, right? And we have 2 of them. Carbon, on the other hand, was in the fourth column, and we only have 1 of them because there's an understood 1 to the right of that C as a subscript. So now let's multiply the 6 by 2, again because we have 2 of them, and that'll be 12 total valence electrons for oxygen. Carbon, if we were to multiply the 1 and the 4, that would give us 4 valence electrons. And if we were to add the two, 12 and 4, we would actually get 16 total valence electrons. Great, but still, now we're not quite ready to solve for the Lewis dot structure. Now we must ask ourselves, which of these two elements are going to be in the center? So again, on the periodic table, we will see that carbon is least electronegative in comparison to oxygen. And again, the least electronegative element is the one in the center. In this case, carbon. So let's draw our carbon in the middle. And now let's diagram our oxygens. And we'll start off with single bonds right here to represent the chemical relationship and the chemical bonding between the atoms. So as we remember, we have 16 total valence electrons to disperse amongst this Lewis dot structure. Great. But we must understand that these single bonds already represent 2 valence electrons. So 2, 4, 6, 8, 10, 12, 14, and that makes 16. Alright, so now we've used up all of our valence electrons. Everything's good, right? Not yet. As you can see, both oxygens are happy right now because they fulfill the octet rule. In other words, they both have 8 total valence electrons. Carbon, not so happy because it only has 4 valence electrons. Again, single bonds already are understood to have 2 valence electrons. So how do we make carbon happy? Well, we can actually take this set of valence electrons and we may move it to the bond in order to create something called a double bond. So let's go ahead and do that. Let's erase these two and double bond. Great. Is carbon happy now? No, because carbon only has 6 valence electrons right now. So we must do to this side what we did to the other side. And another double bond. Great. Now we have solved for the Lewis dot structure for carbon dioxide. Carbon has 8 total valence electrons. Oxygen has a total of 8 valence electrons, and the other oxygen has a total of 8 valence electrons. This is the Lewis dot structure for carbon dioxide. Thank you for watching, and please like and subscribe.